Section 13.2 here is angles in the unit circle. I can work with angles in standard position, and I can find coordinates of points on the unit circle. Big ideas for this section. The measure of an angle in standard position is the input for two important functions. The outputs are the coordinates, called cosine and sine, of the points on the terminal side of the angle that is 1 unit from the origin. Two angles in standard position are coterminal angles if they have the same terminal side. An angle in the coordinate plane is in standard position when the vertex is at the origin and one ray is on the positive x-axis. The ray on the x-axis is the initial side of the angle. It's where it starts. The other ray is the terminal side of the angle, where it ends. And these angles are shown on page 836. So if we look at page 836 on the bottom, they have the initial side on the x-axis, they have the terminal side, and they have the little red line. It might be an arrow. Does it have the little red arrow that goes around to show you how it rotates. Okay, it also has the difference between a clockwise and a counterclockwise there on the bottom. Measuring angles in standard form. What are the measures of each angle on the top of page 837? So the first one for A looks kind of like this. Just our coordinate plane. The angle starts here, and the second leg is here. And this distance, okay, it's counterclockwise, so it's positive, and it's going to be 90 degrees. It makes a right angle here. Remember that a full circle is 360, and that is 1/4 of it, which is a 90 degree. B here looks something kind of like this. Pretend that my axis is straight here. Here, do that in red. Just getting blue. And my angle is like this. Okay, it also tells me that the point right here is at -2, -2. It goes 45 degrees beyond, and we know it's 45, guys, because these are the same values, which means they're the same distance away, which means they're halfway between this axis and this axis. So if this is 90 degrees, this is half of that, which is 45 degrees. So we add those up and get 135 degrees. And since we went clockwise, it's negative. So we get -135. Okay. Positive goes this way, negative goes this way. Now, what is the measure of the angle shown on page 837? Here, our initial side on our x-axis is right here, and our terminal side is that same angle we had before. And again, it tells us that we have a point, -2, -2. Guys, because those are the same, it means that we're halfway. Okay, this would make a square that's halfway. So this is 45. But instead of going clockwise, we're going to go counterclockwise, which means we have 90 degrees, another 90 degrees, and a 45 degrees. The other thing here, guys, is this angle right here is a straight angle, so that's 180. So whether you do two 90s and a 180 and then a 45 or a 180 and a 45, it doesn't matter, because either way we're going to get to 225 degrees. And it's positive because we went up first, we went counterclockwise. Again, remember, a full circle, if we'd have kept going here, that's not really close to a circle, but you get the idea, is 360. And we want just the part of it that we're using, and we're using half of it plus an extra 45 degrees. Sketching angles in standard position. What is a sketch of each angle in standard position? So here, sketch means it doesn't have to be perfect, guys. You don't have to get out like a protractor and measure it. If this is my coordinate plane, my initial side goes on my x-axis. 36 degrees, okay, means it's going to be less than half of the first. Remember, halfway is 45 degrees. We don't even want that much, and it's positive, so we go up. So mine's going to go something kind of like this. And then I draw in the arrow to show my direction. And I'm going to say that's about 36 degrees. Okay, 315. Again, sketches don't have to be perfect. I'm going to start on the initial side. I'm going to go 90, 180, 270, and then I still have to go an additional 45, which means I'm going to split this right in half, about there. Looks kind of like a Pac-Man. An arrow to show direction. And I'm going to say that's 315 degrees. Okay, should have split that one right in half, that quadrant, because, again, this is 90, 90, 90, which means all the way to here is 270 degrees plus an additional 45. Negative 150. Here's my coordinates. Coordinate plane. My initial side on the x-axis. I'm going to go negative, so I go down 90. I need to go an extra 60, which is about 2/3 of the way. I'm going to say that's about 2/3. More than half. It doesn't have to be a perfect third away or 2/3 away, but it does have to be more than half. Okay, guys, these don't have to be perfect by any stretch of the imagination. We just have to have our initial side, our terminal side, and be a little bit more than halfway, because this is 90. This is an additional 60. So this whole thing is 150 degrees, negative 150. Now, what is a sketch of each angle in standard position? Start on our initial side. '85 is close to 90. I draw on my arrow to show which direction I went, and I label it 85 degrees. Negative 320. Initial side. I go 90, 180, 270. Okay, each one of these is a right angle. So they're each 90. Now I have an additional 50, which means I need to go just past half. Okay, half is like here. I went just past. And then make sure we draw on our arrow to show which direction we went. Because it's negative, we went clockwise. And label it as negative 320 degrees. 180. Is a straight angle. So we start on our initial side. Because it's positive, we go clockwise. Or sorry, counterclockwise. And we end up here. Okay, we have 90. We have another 90, which gives us to 180. So this is 180 degrees. Identifying coterminal angles. Which of the following angles is not coterminal with any of the other three? Coterminal means their terminal angles coincide. They're the same. So they all start at the same spot. 300. It's going to start here. I'm going to go 90, 180, 270, and another 30. Negative 60. I'm going to go back 60. And I'm going to end up at the same spot. Because this was 90, 180, 270, this part right here was an additional 30, which means this part is an additional 60, because this whole part ends up being 90. Okay, positive 60. Start on my initial side here on the axis, and I go 60. Since I go in this direction. Okay, so that one does not match up. Let's check negative 420 anyway. So I go 90, 180, 270, 360. Oh, just kidding. It's negative. So I go 90, 180, 270, 360, and then I have to go another 60. And I end up at 400 as well, or negative 420. And I am on my same coterminal is what that's called. So 300, negative 60, and negative 420 are all coterminal because they have the same terminal ray. Remember, a ray has one endpoint, one arrow, whereas 60 does not. So which is not coterminal? The answer is 60. Which angles are coterminal here? So, negative 315, initial side, negative, so I go negative 90, negative 180, negative 270, and an additional 45 degrees. And I should cut that right in half. 45, initial side, oop, and I go up 45, and I'm going to end up at the same spot. $3.15. $90, $180, $270, and now I need to go 45 more. This one is not coterminal because it was positive. If it was negative, like the negative 315, it would have. But it ended up in the fourth quadrant instead of the first quadrant. How about 405 here? I'm going to go 90, 180, 270, 360. Now I need an additional 45. I can't go all the way to the next 90, but the additional 45 is right here. And there we go. So notice how I did show that it went all the way around. I didn't just do this little part right here. I showed that it went all the way around to account for that full circle and then the additional 45. So which angles are coterminal? Those three all ended up with the same terminal side. And I'm going to stop the first video here.